All right, just one problem left. This shouldn't take long. All right, so if we're supposed to locate the center of rotation here, we're supposed to find the place you would hold down the paper and spin it so that this thing lands right on top of this thing. Remember that when the whole thing is over, any point, so point F, when it rotated and it landed on F prime, we'll call it the center of rotation. They always call it O. It kind of bothers me because it looks like a 0. We're going to call it point, I don't know, center of rotation. Let's call it, we can't use C. Let's call it point R for rotation. All right. So the distance from F to R has to equal the distance from F prime to R. And really that's true for all of these. So the distance from E to R has to be the same as the distance, from E prime to R. And the distance from D to R has to be the same. So all these points have to stay the same distance from R as their image counterparts. Well, the way to kind of solve this equation geometrically, like where are all the points where R could possibly be so that they're the same distance away from F and F prime? Well, certainly if there was a midpoint, that's a possible location for R, but it wouldn't have to be on the midpoint. In fact, we talked about this, I don't know, like a semester ago. There's a whole class of points that are equidistant from F and F prime, and that's called the perpendicular bisector. Any points on the perpendicular bisector of the segment that connects F and F prime, like this point here, is going to make an isosceles triangle. This is a horrible picture. But those are all possible candidate locations for R because they are equidistant from F and F prime. So we're going to do that. I'm going to make nicer lines because I want this to be somewhat accurate. Okay. So here, let's connect F and F prime. And this isn't my, why is that purple? This isn't my candidates for locations of R, but the perpendicular bisector of that is. So if I could make a perpendicular bisector here of FF prime, that's all the places, according to where the F's are, where we might possibly find R. R is somewhere on this line, okay? But we can do that somewhere else. Let's say we're gonna connect, I don't know, I said this one next, right? E and E prime, that one's kind of the same direction. Let me do B. You could use any of them, but I think it's going to make a better example if I use BB prime. So now just looking at that red segment, and I just did this with eyeball. You could do it with a ruler, being a little nicer. Midpoint's around here. I want to make a perpendicular, so if I drew a perpendicular bisector in here, it should look something like that. It's pretty darn good. So all the, and again, whoops, that's not what I want. So it was perpendicular. Please, yeah, so it's perpendicular and these red things are like the same distance. That's from here all the way to there. So R has to be on here too. Well, if R has to be on this long red line, it has to be on this long purple line, guess where R has to go? R has to go right here. This point here has to be the center of my rotation. This should remind you of when we did circumcenters with a Mira. We did circumcenter and you had to find perpendicular bisectors of more than one side. This point here is the center of a circle that goes through all 3 corners of the triangle. Same thing here, because B prime is on the same circle. There is a circle centered at R that connects B and B prime. There's a circle centered at R that connects F and F prime. They're different sized circles, but R is where the center of both those circles has to be. Okay, so now if you erased all this other junk and you just looked at this picture again and looked at that point, does it make sense to you that F could rotate around there and go to F prime? Okay, and that E could rotate around there and make E prime. Again, is E, R the same as E prime R? It looks like it is. B, R, B prime R, sure. D, R, D prime R, yeah, they look the same. C, R, C prime R, yeah. Compared to the reflections section, this kind of stuff, this rotation stuff, is harder at the end to look at and make sure you did it right. In the reflections, it was really nice because you got this like butterfly ink blot symmetry, like almost like you could fold the paper and see if you got it right kind of thing. This is a lot weirder. Sorry about that. There's one other thing about rotations I don't remember saying. Is about how rotations preserve orientation. I wonder if it said that around here somewhere. It seems like I said it in class when I taught this, but I don't remember here. The orientation of things in a rotation stays the same, whereas a reflection reverses them. So if I labeled this thing B, C, D, E, F, think about that labeling system, B, C, D, E, F, that's clockwise around the figure. Same over here, B prime, C prime, D prime, E prime, F prime is also clockwise around that figure. These figures are not reversed orientation. These are not mirror images of each other at all. They are the same figure, just tumbled around. Okay, I've talked long enough. I said this part would be short. I'll see you in class.